are going to build on what we already know about unit rates and how they make comparisons easy by doing the next unit. And here's the I can statement. I can compute unit rates using fractions. So we'll write the word fractions right here. And again, don't let that scare you. We're going to do a quick warm-up here. It says find the unit rate for each situation, include appropriate labels. So it says Maddie can do 19 problems in 4 minutes. So we could do minutes per problem or problems per minute. It would probably be better to do problems per minute. So let's do 19 problems in 4 minutes, or we could say per 4 minutes. And then again, with a unit rate, we want this to be a 1. So we're going to divide both the top and bottom by 4. So this is going to be 1 minute here. And then let's see what we get when we divide 19 by 4. So let's see, we get 19 divided by 4, and we end up with 4.75. So 4.75, and that would be problems per minute. So we could leave it like that. I mean, if you really wanted to, I mean, you could write this as, let's see, this would be 4 3/4 of a problem per minute. No problem there. Either way would be totally okay. So fine there in fraction form or fine in decimal form. It's kind of a story problem, so we're okay with either one. And then Josh takes 45 minutes to go 7 miles on his bike. So would we do miles per minute, or would we do minutes per mile? Well, at this point, I mean, if you know any bikers, I mean, some of them figure out how many miles per minute they go, but a lot of times they do minutes per mile. Like they can bike a 2-minute mile, or you can run a 5-minute mile, or different things like that. I mean, in gym class, I mean, a lot of times we're aiming for something under 12 minutes, so I can run the mile in 12 minutes. So it really doesn't matter on this one. Usually we put the time on the bottom. So I'm going to do this this way. I'm going to do 7 miles in 45 minutes. And then we'll go ahead and we'll compute what that is. So we're going to divide the top and bottom by 45. So if I divide by 45, now this does not work out very nicely. We can't reduce that or anything. So let's do 7 divided by 45. And 7 divided by 45 is 0.155. So I'm going to round to the nearest hundredth. So I'm going to, instead of doing 0.15, I'm going to take that 5, bump this up to a 6. So this is going to be 0.16. So this is going to be 0.16 miles per minute. So they're running about a 1/6 of a mile per minute. Now, just for the heck of it, I'm going to change colors here, and we're going to flip this over. What would happen if we did 45 minutes for 7 miles? And if we did that unit rate, we get something that's different and may in some cases be a little bit better. So let's do 45 divided by 7. And again, you really can just carry out this division, because we know the bottom's always going to turn into a 1. So this is for 1 mile. And what did we have here? We had 6.428. So that 8 is enough to bump that up to a 3. So 6.423. So 6.43. Is that what we had? Yep, 43. Okay. Minutes per mile. Okay, so either one of those would be totally okay. This is minutes per mile, and this is miles per minute. Again, this is a little bit more standard, but there are occasions where this might be a little bit more useful, especially in a particular story problem. So now let's talk about unit rates with fractions. They are definitely more difficult. I mean, if we're working with whole numbers and integers and that sort of thing, it's definitely easier. But there are several techniques that we can use for computing unit rates with fractions. What we're going to focus on is we're going to focus on the technique that uses division. So this technique that we're going to work with uses division, and we're going to really be dividing fractions. So if you remember, to divide two fractions, we multiply. We never really divide two fractions. We always multiply by the reciprocal of the second fraction. And we always do this. Whenever you're doing multiplication of fractions, you always try to cross cancel. Whoops. Cross cancel. All right, and what this does is it makes sure that the answer that we get is already in simplified form, and that's really useful, and then we don't have to work with really big numbers and stuff like that. So what we're going to do on these following problems is we're going to find the unit rate by using division. And since they're story problems, it would be good to think about what's the best way to write the answer. Fraction, decimal, should we have, in this particular case, gallons per minute, minutes per gallon, and different things like that. So it says a faucet can put out 3/4 of a gallon in 2/5 of a minute. What is the flow rate in gallons per minute? Well, there it is right there. It says we're going to do gallons per minute. So it tells us which one we want on the top. So we're going to do the 3/4 of a gallon on the top, the 2/5 of a minute on the bottom. We're going to remember that we've got gallons on top and minutes on the bottom. If you want to write those, you can. But remember, we're going to divide this fraction by multiplying both top and bottom by the reciprocal. So we're going to multiply the top by 5/2. And then we're going to look for things that we can cross cancel. So we can't cross cancel the 3 and the 2, and we can't cross cancel the 4 and the 5. Gosh, if the 2 were up here, we could do some cross canceling, but on this particular one, we can't do anything about it. So what we end up with is 3 times 5 is 15 on the top. 4 times 2 is 8 on the bottom. So we get this, 15/8, and this would be gallons per minute. Okay, now I'm going to write it like this. We could also do this, 15/8 gallons per 1 minute, like we were writing before. Either way is totally okay. They mean the same thing, and we would kind of read them the same way. But these both kind of tell a story. So this is 15/8. This is almost 2 gallons per minute. If you wanted to, you could grab your calculator and we could figure out what 15/8 is. Or maybe you already know that number should look kind of familiar if you were into memorizing those common rational numbers. We could say 1.875 gallons per minute. Okay, so anything like that would be just fine. The key here is to know how to carry out this division or figure out this unit rate when we're dealing with fractions. So let's take a look at the next example, and this is a great one. This is actually true. Joey Chestnut, he's a competitive eater. He goes around the country and eats pizza and hot dogs and all sorts of stuff. In this particular case, he's in a buffalo wing eating contest. So it says he can eat 1 1/3 buffalo wings in 1/6 of a minute. Now, there might be a better way. I mean, this is a math class, so we kind of make things to work for us. These are both written as fractions. You could just as well write these in seconds for this time here, and we could write a decimal for this, and maybe it would be a little bit easier. But we would have to use a calculator most likely to figure those out. So how many wings can he eat per minute? Wings per minute. So the wings are going to go on the top. So I'm going to change this to 4/3. Remember, 3 times 1 is 3 plus 1, so we've got the 4/3. 4/3 of a wing, so a little bit more than 1 wing, in 1/6 of a minute. So 1/6 goes right here. So we're going to take this, we're going to flip it over, and we're going to multiply. So I'm going to flip this over. There's the reciprocal. I'm going to look to see if we can do any cross cancellation. I can. The 3 and the 6. 3 goes in here once, 3 goes in here twice. So notice what we've got here. We've got a 4 and a 2 on the top, so that would be an 8. A 1 and a 1 on the bottom, so that would be a 1. And remember, the top is wings, and this would be 1 minute. So he can eat about 8 wings a minute, and that's actually a pretty accurate figure. So we could write it like that. We could also write it as 8 wings per minute. And again, the nice thing about writing the 1 right here is reminding us this is what makes a unit rate. The denominator is a 1. We're always making comparisons with 1, so that if we had somebody else that could eat a different number of buffalo wings in a different fraction of a minute, we could then convert that into a unit rate, and then we could make a comparison. And if they ate more than 8 wings, we know they're faster. If they ate less than 8 wings, then they eat slower. So that's how we do that. And then let's take a look at a couple of problems from your assignment. So this is number 3. It says a garbage truck collects 2 3/4 of a ton of garbage every 1 1/4 hours. How much garbage does it collect in an hour? So again, weird way to gather data and information, but we're going to go with it. And it says, how much garbage does it collect in an hour? So this would be like garbage per hour. So we're going to do the garbage on the top, and again, I'm going to go ahead and change this to an improper fraction. So 2 times 4 is 8, plus 3 would be 11/4. We're going to divide that by 1 1/4 hours, which would be 5/4. And you'll notice what's going to happen here when I take this and I flip it over. So the 4 goes on the top, the 5 goes on the bottom. Look at those cancel. So we get 11/5, and that would be tons per 1 hour. Whoops. 1 hour. Okay, now we could leave it like this. This wouldn't be too bad. If you wanted to rewrite it and you wanted to do 11/5 tons per hour, that would be totally okay. It might even be useful, because this is a story problem, to go ahead and figure out what this would be. 5 would go in here twice with 1 left over, so this would be 2 1/5 tons. Or you might remember what this is a decimal. That 1/5 is a common rational number, so we should know what that is. So about 2.2 tons per hour. And you get to choose the best way to write it. This is probably a pretty good way right there. Anyway, that's how to do one problem on your assignment. And here's another one. Some of the problems on your assignment, they're kind of story problems. They're kind of unit rates in context here. And then others, they just give you just the bare bones information. On this one right here, 1/3 of a gallon in 1/6 of a minute. So if you were doing something like this, you'd want to think, okay, do I want to do gallons per minute, gallons on top, minutes on the bottom, or do I want to do minutes per gallon? There's no right answer, but again, most of the time we put the time on the bottom. So let's go ahead and do that here. Let's do 1/3 over 1/6. We're going to take this, we're going to flip this over and multiply. So this is going to be 6 over 1. So the reciprocal of 1/6 is 6 over 1. We're going to look to do any cross cancellation that we can. 3 goes in here once, 3 goes in here twice. So look what we've got here. We've got 1 times 2 on the top, so that's a 2 on the top. We've got 1 times 1 on the bottom, so that's a 1 on the bottom. And then remember, we did gallons on the top and minutes on the bottom. So there's our answer, and we could even simplify a little bit more. There's nothing wrong on these particular problems with leaving it like this, but we could also write 2 gals per minute, and we'd be just fine right there. Okay? All right, there you go.